All right, so in this video, we're going to study trig limits. And the limit I have up on the screen, this is one that you're really going to want to make sure you know. Limit as theta goes to 0 of sine theta over theta is always going to be equal to 1. Now, I don't expect you to believe me initially when I say that, but to convince you of it, you've got two options. Your first option is to take a look at figure 2.32, which is on page 68. It'll show you the graph of this, and it will in fact show you that the limit is equal to 1. You could also, if you really don't believe even the author of the text, you could numerically approximate it like we did in an earlier section, and you would find out the limit would go off to 1 there as well. So knowing that is going to be very, very helpful in a lot of these examples that we work. So I'm going to go ahead and I'm going to clear the screen real quick so I have enough room to work this next example, but this is one limit that you would want to have memorized. All right, so we're going to take a look at an example here. Limit as x goes to 0, cosine minus 1 over x squared. So always start, take the number, throw it in there, see what you get. In this case, it looks like you also hit that indeterminate form, the 0 over 0. So we still need to figure out then how to manipulate the function. So in order to do this, similar to a couple other problems you've seen, I'm going to go ahead and multiply the top and the bottom by cosine of x plus 1. And if you can't quite see what it's going to do for us yet, you will here in just a minute. So we'll go limit as x goes to 0. Remember, guys, keep that limit notation all the way down until you get rid of all variables after evaluating. So this will give us cosine squared x minus 1 over x squared times cosine x plus 1. Now, in the numerator, that's an identity. Cosine squared x minus 1 is actually equal to negative sine squared x. And again, I'll leave that denominator alone. And at this point, I'm going to go ahead now and break everything apart. And what I mean by that is I'm going to use my limit laws and take a negative sine x, another sine x, and then a 1 over cosine x plus 1 with an x there and an x there. Now, it might seem a little random why I did what I did, but before I get into my explanation, just work with me here for a second and confirm that what I have up here is in fact the same thing that I have down here. My negatives, two signs there and there, my x squared, so an x and an x, and then a 1 over cosine x plus 1 would be this guy here. So I've just split it apart. Now, using those limit laws, I know that I can distribute my limit into each one of these as a product. So when I look at this first one here, the limit as x goes to 0, sine x over x, that's going to give me a 1. So I'll have a negative 1 out of this guy. So I'll have a negative 1 from that guy. The limit as x goes to 0, sine x over x is going to be a positive 1 out of that guy. And then when I evaluate this one, this is actually going to give me a 1/2. So a negative 1 times a 1 times a 1/2 gives us a negative 1/2 for our final answer. So not only are we now manipulating the function to create it's something different, we're actually now splitting it apart in such a way that we're able to compute these individual limits as well. Now, this limit here in particular shouldn't be much of a surprise that we got a negative 1/2. This is actually the one that we worked a couple sections ago numerically approximating it. So if you go back and check your notes, you can see we came up with a negative 1/2 now a couple different ways, this of course being probably the most efficient. Okay, so for this particular problem, we're going to go ahead and treat it kind of the same way, but there's going to be a few things here that we need to also mention, and then a little bit of algebra as well that we're going to have to discuss. We got a limit as theta goes to 0, sine 6 theta over sine 8 theta. Now, I do want to point out to you one as kind of a sidebar here. We know that the limit as theta goes to 0 of sine theta over theta is equal to 1. What I haven't told you yet, and I would encourage you to graph this again, you can go to Desmos and graph this, as long as you have the same a theta on top and bottom, that's still also going to go to 1. So if that's going to be a 6 theta, so sine 6 theta over 6 theta, sine 8 theta over 8 theta, it will still go off to 1. And that's what we're going to have to use here. Now, once again, I'm going to kind of go through this a little slower and split it apart into our sine 6 theta separate from our 1 over sine 8 theta. Now, I'm going to need to create, if I want to take advantage of my property over here, I'm going to need to create a 6 theta down here. Now, these are expressions. I can't just do anything I want to. I've got to make sure to do it legally so that when it multiplies in, it essentially cancels itself out. So I need a 6 theta down here. So I'm going to go ahead and put a 6 on the bottom, but I can't just put a 6 on the bottom. I also need a 6 on the top. Okay, so now if you look at what I have in blue, when I multiply that together, that just gives me 1, but that's okay. I've still got it to where it needs to look. I also need a theta, so I'll put a theta on bottom, but I can't just put a theta on bottom. I also have to put it on top. It's got to be something over itself to equal 1. So because the limit is with respect to theta, I can't put the theta outside of the limit like I did the 6. 6 was just a constant. You can pull a constant outside of a limit. So the theta will have to stay inside the limit, and it'll have to go on the top of something. Well, conveniently, I need one there. So I'll put my theta. Also on that sine 8 theta, I'll need an 8 on top and an 8 on bottom. So if you look at all of that blue stuff, if you multiply all of that blue stuff together, it all divides off into 1. So I've just changed the way it looks, not what it actually is. I pulled all constants outside of the limit. That's one of our limit laws. And all of my thetas, my variables, I had to keep inside the limit as I've done. Now, the 6 over 8 that sits out there, that can clearly be simplified down to 3/4. And just a moment ago, I told you that this guy right here, because of our argument over in green, this is going to go off to 1, and it does. Now, what that leaves us with is this guy right here. And this is pretty much the reciprocal of what I've been telling you all along. So the question is it legal to say that this goes off to 1? And the answer is yes, and I'm going to show you why. Now, you don't necessarily have to show me this step every time, but I do think it's going to be important to see for most people. All right, so I've got my sine 6 theta over 6 theta, and then follow me on this. If I take this divided by this, that would be the same thing as this multiplied by the reciprocal of this, which turns into be what we had up here. So I know moving from here down that that's legal. And so also I know it's legal to take the limit into both the numerator and the denominator. So you can see now this limit also is going to go off to 1. Okay? So back up here to our original problem. I'm perfectly confident that everybody sees now that goes off to 1. But having shown the work that I have here, hopefully now everybody's confident seeing that also goes off to 1. So the final answer, when all is said and done here, is just going to be your 3/4. Okay, so there's, again, a little bit of new stuff going on there with respect to this green property over here. We've kind of taken it up a notch, as well as the algebra being convincing enough to go from here to here and create our 1 from that limit as well. So take a little time and play around with that if you need to on your own to make sure you have a better grasp of it. Now, the last thing I'm going to mention is kind of just more of a reminder than anything. Tangent of theta. Well, if we're going to take advantage of the property like you've seen in the last two examples, we're going to want the sine to be there. Just remember, tangent of theta is sine theta over cosine theta, and that will then allow you to manipulate as needed and hopefully get that limit going off to 1 for those individual parts. So just remember that. And remember all of your trig identities for that matter, but tangent's one that'll probably sneak up on you in this section.